Welcome and thank you for listening to this Paragon Edge audio blog. As ATM testing evolves, automation is no longer the end goal. It becomes the foundation. Once teams have established automated testing and scaled their capabilities, the next challenge is ensuring quality keeps pace with modern development cycles. This is where continuous assurance comes in. By integrating automated testing directly into development pipelines and removing traditional constraints, ATM teams can shift from periodic validation to continuous confidence in every release. In previous stages of the journey, ATM teams introduced automation and then expanded it by developing new skills and building virtual environments. By this point, automation is no longer an experiment. It has become a trusted and reliable part of the testing process. The question now is how to take the final step and move from automated testing to continuous assurance. In many ATM environments, there is still a familiar tension. Developers are working quickly, delivering new features and updates at an increasing pace, but testing, even when partially automated, can still lag behind. This creates a gap where code is ready, but testing is not complete. Releases are delayed while regression cycles run, and defects are discovered later than they should be. The result is something every organization wants to avoid: defects escaping into production. The final step in the journey is about closing that gap. Once automated test suites are well established, they can begin to integrate directly into the development lifecycle. Instead of running tests only at the end of a release cycle, they can be triggered automatically when new code is committed, when a build is created, or when a release candidate is prepared. This is where ATM testing begins to align with modern continuous integration and continuous delivery practices. Automated regression suites can run overnight, on demand, or as part of every build cycle, and they run the same way every time. This consistency allows defects to be identified earlier when they are easier and less costly to fix. At this stage, one challenge often remains. Many ATM environments depend on external systems such as core banking hosts, transaction switching networks, and third-party processors. Access to these systems is often limited, testing windows may be restricted, transaction volumes may be controlled, and repeated testing may not be practical. This is where host simulation becomes a powerful enabler. By replicating host behavior within a controlled environment, recording real transaction interactions and replaying them, and simulating responses without needing access to live systems, teams can remove these constraints. From the ATM's perspective, nothing has changed, as it continues to communicate with what appears to be a real host. From the organization's perspective, everything has changed. Testing is no longer constrained by the availability of external systems, third-party testing windows, or the risk of overloading production-like environments. Teams gain the freedom to test as often as they need. When virtual ATMs and simulated hosts are combined, a fully virtual test ecosystem emerges. In this environment, ATM devices are virtualized, host systems are simulated, transaction scenarios are automated, and test execution becomes continuous. This allows ATM test operations to run thousands of transaction scenarios repeatedly, simulate edge cases and failure conditions, validate changes across multiple ATM models, and execute full regression suites without physical constraints. What once required coordination across multiple teams and systems can now be executed from a single, controlled environment. At this point, testing is no longer a phase. It becomes a continuous process. Every code change can be validated, every build can be thoroughly tested, and every release can be verified with confidence. This is what continuous assurance means. It is not just about automation, but about creating a system where defects are detected earlier, feedback loops are shorter, and quality is built into the development process. Instead of asking whether something has been tested, organizations can begin to ask whether it has been continuously validated. When this level of maturity is reached, the benefits extend far beyond the test lab. Developers gain faster feedback and can fix issues earlier. Product managers gain confidence in release timelines. Operations teams experience fewer production incidents. Customers benefit from more reliable ATM services. Most importantly, the organization gains the ability to innovate with confidence. For many ATM teams, this journey began with a simple step: a small sandbox, a handful of automated tests, and a curiosity about what might be possible. From there, it evolved into a scalable automation capability, a more skilled and empowered team, and a fully virtualized testing environment. Ultimately, it leads to a fully integrated, continuously validated system. This is not a radical transformation, but a series of practical, achievable steps, each building on the last. Across this journey, three stages emerge. The first is getting started with a small, low-risk step into automated testing. The second is scaling capability by building skills, expanding coverage, and growing confidence. The third is continuous assurance, where testing is integrated into the heart of the development process. Each stage is valuable on its own, but together they form a clear and achievable path forward. Every ATM operation is on its own journey. Some are just beginning, some are already scaling, and some are ready for full integration. The important thing is that you do not need to take the entire journey at once. You only need to take the next step. Thank you for listening today.